Hey everybody, welcome back to Tech Talk Education. I am sorry that I missed you for 1 week. I've been working on a book and I was really under the gun to get some chapters done, so I was writing rather than producing content. But we're back here, and what we're going to do now, I don't know if you've ever heard of a Linux term called symlink, stands for symbolic link. What we're going to do is we're going to learn about what those are, how to create them, why they exist. So this is really interesting. It's just a little bit deeper nugget of Linux. That's something that you'll probably be concerned about as you're studying Linux. And so let's learn about it. Let's get started. Okay, now I'm working in Windows 11 here. And I'm sure you guys have noticed this, that you'll have on your desktop what are called shortcuts. If I'm being honest with you, I don't like shortcuts very well. I like a nice, pristine, clear desktop. I even get rid of the recycle bin on my desktop. But a lot of people have dozens of shortcuts on their desktop. So let's create a real quick Windows one, shall we? So I'm going to right click. I'm going to select New, and I'm going to select Text Document. And I'm going to call this Hello World, like so. So here's my new little text document. And now what I want to do is I'm going to go in and right click and go into Properties here. And you can see that it's telling me that it's a text file that's on my desktop, and there's a specific location where this is kept. This is a Windows location. And you can do some other things. You could add the NTFS permissions for it and get the details for it and all that. So that's a file actually living on the desktop. I'll get rid of that by marking it. Let's go ahead and create a shortcut instead. So I'm going to say, I'm going to go to New, Shortcut. And now what I'm going to do is browse out somewhere and just find something. So let me browse out. I'm going to go to, I'll go to this PC, C:, I'm going to go to Program Files. Let's find something here. I think Internet Explorer's still out there, so let's see if that's, yep, there it is. There's Internet Explorer. I'll grab this guy. Where is it at? iExplorer.exe. Click OK, and then click Next. And I'm just going to call this IE and finish. Now that's a shortcut. So there's a difference between having a file right on your desktop, which you can do in Linux as well, and a shortcut which points to a file. Now if we right click this guy and go to Properties, we can see that it's pointed to somewhere else on the computer, and then it's going to start in there. We could add a shortcut key. We could determine the size of window we want to run it in. We could change the icon. That used to be a lot of fun where people would play a prank, like it would be a good April Fool's joke where somebody has all of their icons all over the place, and there's like 250 of them on the desktop, and you change one so it's a different picture but it's the same link, and people get so frustrated with that. Then there's the Security tab, of course, and Details. So this is a shortcut. So Windows does support shortcuts. Does Linux? Well, that's the next thing we want to do. So I'm going to go ahead and move from here. I'll get rid of this because I really don't need it. But you could double click it and it would run IE. And I'm not sure why you would. It's not even supported. Well, it is supported in Windows, but the new Edge browser is the one that Microsoft wants you to use now. Anyway, so I'm going to go ahead and get Kali up and running, and we'll look and see if the same thing happening in Linux, only it's a little bit more. There's a little bit more to it. Okay, so here's Kali Linux. And what I'm going to do, I'm bringing up the terminal window, and I want you to know about a thing called an inode. Now this is very, very weird. I guess I don't know why I have PowerShell. I must have hit the wrong icon here. I'll bring up the terminal here. And so Linux has a thing called an inode. And the idea is that Linux is a file-based system, so it's keeping track of everything based upon numbers and files. And so when you go out to memory and you assign, the location of a file to something, it gives it a number, and the number is called an inode. So for example, if I do an ls here, I get some directories here, but if I do an ls tac al, I'm going to list everything long, I get a bunch of directories as well as their associated permissions. And I have done movies on what these permissions are all about. So a dot means that it's a hidden folder, this is a hidden file, and so forth and so on. So that is what we're looking for. But now let's go look at the inodes. So I'll clear the screen, and if you do a ls tac I, it's going to show you the inodes. Now it applies an inode number to a file and to a folder. So you can see here that I've got all these directories. Linux calls them directories. You can interchange the terms. Today the term folder is very, very common. I remember teaching a class, gosh, 25, 30 years ago, and I had the idea, well, hey, you know, that's like a folder like in a file drawer. So I had a person get me some file folders and tried to explain that to these people I was teaching DOS to, and it was just lost on them. They had no idea. But directory, folder, they're all the same, and Linux calls them directories. So you can see the inode number here. It's 3145778. This number will not change, and it is a number that's associated with the memory where the folder is stored in the Linux system. Linux is all file-based. So that's something that we need to know about. We need to know about the inode numbers. Now, can I clear the screen? You know what? Can I do an ls tac ial? Can I do that? Can I string all of those options together? A means that I'm going to show all files. It's going to include the visible files, the invisible files. L means long, so it's going to give me a long list with all the permissions, and I stands for inode. So let's see what that looks like. Works just great. I can scroll up through here, and I can see I've got a .java folder here that is hidden, and it is a directory. There's a D right there. And then here's my inode. Now this is something that I have a little bit of a beef with Linux, and we'll see this in just a minute what this is like. Anyway, I've got a D here, and that stands for directory. There's not going to be an F there for folder. It says D for directory. And you have a lot of different hints that you're given as to what this directory, why this is a directory. First of all, today Linux color codes most stuff. So the color coding tells you that this is a directory. Even though it's a hidden, it's a directory. And then you have its inode. You have, you know, the user Kali is allowed to use this directory. Group Kali is allowed to use this directory. So this is the user, this is the group. So what's the deal with that? Well, when you create a Linux, when you install a Linux distro, you create a user account, and there's a group created for that account. Well, you can add other users to that group, but normally, you know, especially when you're experimenting around with it here in like Kali Linux, it's just Kali is in the group. Well, so these permissions right here are read, write, and execute. That is for user Kali. Anyone else that's in the Kali group, like let's say Fred is made a member of the Kali group, will only have read and execute permissions. And then there's a special group called world, and that is anybody that is not Kali user and that is not a member of the Kali group. They also get read and execute. So let's say that you have a user Sally. Sally is not a member of the Kali group. Sally can still read and execute files inside this folder, but she cannot write files, so she can't create files. She can look at them and execute them. So that's how you read the directory structure, the bits that are showing the permissions here. And that's all well and good, and I've done movies on that before. You also have its size and then the date that it was created, date and time. Now, you're looking here at a lighter blue folder. This is a directory. It's really not a directory you might be tempted to think it is, even though it's in this blue. It's a little bit lighter blue, and the color coding will be different based upon you and what you have set for your particular version of Linux in a terminal. You can adjust these settings differently. But the point here is that this is a file. and it is a file that is pointing to another file. So this is what is called a sim link. It is a symbolic link, meaning, hey, if you decide to use the .face.icon file, what I'm really going to do is I'm going to use the .face file. It's a pointer to .face. Now this gets at the idea in C, C++, and C# languages, the idea of a pointer. And what a pointer is doing is it's pointing to a memory area of memory in like the C language. But in this case, what we're doing is essentially the same idea. We're taking and we're saying, well, I've got this file out here, and I'm going to point to another file called .face. And it's super common. And look at this. If I look at the permissions here, I get an L. Now, L stands for symlink. Now, this is called a soft link. There are soft links, there are hard links. When you see a file in a light blue color, or whatever color your system shows you, and you see an arrow, and you see another file name or folder name, this is going to be a file though, you know that you're looking at a symlink, and it's also called a soft link. So we've got to figure this out. And so what I'm going to do is clear the screen, and we're going to go ahead and just create a folder, file. So I'm going to say touch hello_world. Creates an empty file. I'm going to do an ls for hello world. Now this thing turns black. That's really good. That's color coding, and what it's doing is telling you, Kali is telling you, yep, there's a file out here by that name. That's all good. If you didn't have it in bold, you would know that you do not have a file of that name. And so it shows me hello world. And if I do an ls tac l hello world, like this, and hit enter, it's showing me that it was created today. It's a 0-byte long file. It is a file, not a folder. I can tell because the dash is here. That means that this is a file. That's all good. Now the touch command creates an empty file for you to edit. So let's go in and edit this thing. So clear the screen. I'm going to use my favorite editor. I like Nano, so I'm going to do Nano Hello World. There are tons of other Linux editors. And I want to refresh your memory that when you see this little caret, this is called a caret. It's an uppercase 6. You don't type in uppercase 6. Caret is a metaphor for the control key. So when you see caret O, it's telling you hit control O. So let's do this. I'm going to type in hello world. It's snowing outside in late April. And you see a star here, and the star is telling you there's data inside the file that has not been saved. Now, how do I save this? Well, I could do Control X, and it would say, well, you've got to save it first, which is fine. But what I normally do is I do a Control O to write out. So I do a Control O, and it says, oh, do you want to update Hello World? Yes, I do. Hit Enter. And then I'll do a Control X to exit. And if I do an ls tac l Hello World now, oops, clear the screen, ls tac l Hello World, I can see here that it now has 50 bytes in it. Okay, well that's really good. Now what do we need to do to make a link out of this? So you realize, or you remember, that I said that there was something called a hard link. Now there is a new command that I'm going to give you. It's the ln command, and then what that does is that creates a link. So ln, if you could get that in your mind, is going to create a link of some kind. Let's create a hard link first. So I'm not going to use ln just right now. We'll come back to that. But what I am going to do is I'm going to use the copy command. And I'm going to put an option in here called tac-l. What that's doing is that's saying copy something from here to here and create a hard link for it. So let's see what that looks like. So I'm going to copy from home Kali, hello world. Hell world. Occasionally that's the case. So that turns out in black. Everything's good there. No problem. Kali's telling me, yep, I know about that. It's bolded. Now what we're going to do is we're going to copy it to home right in the same place. So we'll do it, but we'll do hello world 2. I'll put the number 2 on here. Now it unbolds it because it's like, well, I don't know what that is. But we're going to take and copy. CP is the Linux copy command. TACL is saying make a hard link. You'll see what that looks like in a minute. We're going to take this file, which we just created and edited, and we're going to copy it into the Hello World 2 folder, a file. So I hit enter. Everything's cool. Now if I do an ls TACL star hello, what I'm doing is I'm using a wildcard that says show me everything that starts with hello. And let's see if we get anything here. Oops, maybe I need to do it the other way. ls TACL. You know what? I can do hello world star like that and hit enter. And it shows me that I have 2 files here. Well, okay, so here's hello world and here's hello world 2. Would you believe me if I said that they contain exactly the same thing? Let's take a look. So if I cat hello world, it shows me this sentence that we just created. And if I cat hello world 2, it shows me exactly the same sentence. So this is a hard link. I'm going to clear the screen. I'm going to do an ls tac il hello world star. So I'm telling it the star is a wildcard. It's called a regular expression. And what I'm doing it here is I'm telling it, I want you to show me anything that you find that has the words hello world in it first. And I'm also using the I here now because I want to look at this tac I want to look at this inode right here. I want to see the inodes. So I hit enter. Lo and behold, this is an inode for this file. Linux created that inode number. But look at this. Hello World 2 is sharing that inode. So that's the important distinction here. So we're sharing an inode. When we've got a hard link, it's going to share the inode with the original file. Now it doesn't do 2 things, and this is a serious annoyance for me, and I want to show you and put to you both. First of all, you don't see an arrow out here pointing to Hello World. So like you saw with the symbolic link, the arrow, it would say Hello World, arrow, Hello World 2. It doesn't do that. With a hard link, you don't get that. Also, you'll notice here, there's a dash. Now this is seriously annoying to me. Why couldn't Linux just put an H in there so I knew it was a hard link or something like that? You have no way of knowing if you're looking at a file or if you're looking at a hard link. They're identical. Even the permissions are identical. So this is very, very odd. But you should know this is the original file. We know it is because we created Hello World here. But then we created a hard link, and this is a hard link even though we can't tell that it's a hard link. It's exactly the same size. It's Hello World 2. It's pointing to Hello World. And Kali owns it, and Kali has read permissions to it. Kali Group has read permissions. Well, what does that mean? Why would I use this? Well, imagine that you are the president of a company, or you're a big wheel in a company, and you've got this spreadsheet or this little database or something like that that gets updated regularly by your salespeople. And so you've got 3 salespeople or 2, and they need to connect to this file to be able to update it. So that might be a time when they could come in and they could read the file, but they couldn't edit it, and they could not execute the file, but they could read it. And so you could give them access to Hello World 2, and when they type in anything, if they had edit permissions, it would automatically update Hello World. Let's prove that to ourselves. So what I'm going to do is I'm going to nano Hello World 2. And I'm going to say, I guess the snow will go away soon and the flowers will bloom. And my trees are blooming, so they're beautiful. Now you notice that Hello World 2 has a star here. And so I'm going to go ahead and write this out. Control O and enter to write out to Hello World 2. Control X to exit. And if I do an ls tac il hello world star, I see that it now has 114 bytes in it. They're both identical. And so if I cat out hello world 2, it shows me the sentence that we just created. And if I cat hello world, it shows me the same sentence. So we are proving to ourselves that we can edit a hard link and it will actually update the file. So it will update the main file even though you're editing a hard link. Now the only thing you have to be worried about here, right now you can see that Kali has read-write permissions right here. This is a hard link. Kali has read-write permissions to this file and this file. Members of group Kali would have read-only. So the thing you would want to do, like with the salesman example or the salesperson's example, is you would need to add them to the Kali group, and then you would need to update the permissions for the group so that they could read and write. You'd give them an RW. And I've made a movie on how to adjust permissions using the chmod command before. And so you can see that these two are identically the same, and they share the same inode. Okay, that is a hard link. Well, what happens if we do a soft link? I'm going to go ahead and clear the screen. Now you remember that we were using the copy command. So you can use copy to take a file that you have, copy it to a hard link, and give it a new name. And then what Linux will do is it will share, it will use that same inode, and then when anyone makes an adjustment to this file, it's going to make an adjustment to the main file. We can do the same thing with a symbolic link. So let's do that. So we're going to copy. This time instead of TAC-L, we'll use TAC-S. And I'll tell it, oh, you know what? I want to copy home Kali hello world. And it sees it. And now let's make a new file. So we'll make home Kali. Let's call this hello world 3, shall we? And hit enter. Okay. Now I'm going to do an ls tac-il hello world star. I now have 3 files out there. Well, let's take a look at this because this is kind of different. So check it out. So hello world 3 is in a light blue. It is a file. It is not a directory. It is pointing to hello Kali hello world without any numbers. And there's an L here which tells you that it is a symbolic link. Here's the important part. It gets a read, write, and execute, read, write, and execute, read, write, and execute. So this might be a better fit for your salespeople because you're giving them a pointer to hello world. You're using a symbolic link to do that. They have write capabilities, but they don't have those capabilities on the original file. So they could not pull this up and edit it, but they could pull up the symlink and edit it. So that's it's not a Windows shortcut, but it's acting like a shortcut, I guess is the way that you can say that. So this is a symlink, and you notice here that it has a different inode number. Now I'm going to give you the rule. The rule is if you have a hard link, you must delete the inode numbers associated with that link before you can delete the file. So if you have a file that has a hard link or a soft link tied to it, you must delete the inode numbers first. All right, well, so that's very good. Let's practice writing again. So let's say we want to nano hello world. This time we'll nano hello world 3. And hit enter. And it keeps the sentence, so it's getting the sentence out of hello world here. It's really cool. And I'll come down here and hit my enter key. And what should we say? I feel bad for the spring birdies, though. They must be frozen. I guess you can probably figure out we had a late spring snowstorm, and so it's got the trees covered, and I assume the animals just hide away and wait it out because in the springtime the snow goes away really rapidly. Okay, so now we've added a third line here. So I'm going to go ahead and write it out. Control O, enter. Control X to exit. Clear the screen. And oops, wrong one. Clear the screen. Let's try our handiwork. So let's cat hello world 3 and hit enter. Boom, there's my line. Let's cat hello world 2. Boom, there's my line. So it updated the symlink and the hard link. Let's cat hello world. boom, it updated the primary file. So this is really cool. This is a way that you can create a link to a file, and then when you use the file, it will update the primary file. And this is really, really very ubiquitous in Linux. You'll see this a lot as you're looking around. I'm going to clear the screen, and I want to show this to you. So again, so I'm going to do ls tac il. Oops, clear the screen, ls tac il, and I'll do hello world star. And you can see here now, you can tell that I've got a symlink here. How can you tell? There's an L in this first bit. That gives it away. It's a symlink in L. And the inode number is different. Now, if I'm looking at these two files, the way I can tell one of them is a hard link is the inode number is identical to the other file. One of these things is the same as the other. However, I wish they would have put like an H here or something like that to designate and more readily point out that it is a hard link, because it's a lot more difficult to tell. Okay, well, so that is the copy command. Now how do we do like a hard link using the ln command? Well, this is another odd thing. So let's go ahead and we'll just type in ln. Now, if you don't specify any options, it's going to automatically create a hard link. So let's tell it we want to get home Cali, and we're going to do hello world, and we're going to put it into home Cali hello world 4. 4. And again, Cali says, oh, this is bold. I know about this file. I don't know about this file. That's fine. It'll create it. Boom. There we go. Clear the screen. ls tac il hello world star. Boom. There's my hard link. Notice here, guys, it's sharing the same inode as the other two. So we can really easily tell that these are hard. There's two hard links involved here. Our only problem is we don't know which one is the actual hard link. It's got the same data in it as before. And you notice here that with our soft link, it's only 22 bytes long. Why is that? Well, that's because we keyed in that sentence inside the soft link. We didn't pick up the other two sentences from the hard links or from the actual file. All right, so that's how you create a hard link. How do you create a soft link? Well, it's a little annoying with me that you use ln with no option and you create a hard link. I wish they would have capped the tac L thing, but they didn't. So it's just ln blank. But if you do an ln tac S, it's telling you that you're going to create a soft link. And it's just so odd to me. You know, and I guess people are, back in the day, so a lot of this stuff is pretty old. I'm going to make hello world 5 and clear the screen. You know, maybe they didn't talk to each other when they were making the commands or doing what, I have no idea, but it doesn't matter as long as you understand what's happening here. So here's hello world 5. It's a light blue. It's got a pointer. It's pointing to hello world. And so this is a soft link. You can recognize it because it has an L in the number 1 bit position. And then we get all these permissions. This is technically 777. And I have a movie where I show you how to add up the values of these permissions. But if I were doing a chmod, I would chmod 777, and it would wind up giving all permissions to this particular file. We don't need to do it because it already has done it. Notice as well, this inode number is different than this inode number, but these three inode numbers are alike because two of them are hard links. Now let's try this out. So I'll clear the screen. I'll do a nano, and I'm going to do hello world 5. And I'm going to say, summer's on its way. Control O to write out. Control X to exit, clear the screen, and let's do our cat. So we're going to cat hello world 5, got it, cat hello world 4, got it, cat hello world, let me clear the screen. So you get some screen real estate here, clear, cat hello world 3, got it, cat hello world 2, got it, and then finally clear the screen and cat hello world. All of them say exactly the same thing. And again, if I do a clear screen, ls tech il, hello world star, I notice here that this guy got 22 bytes. These guys were updated with 192 bytes. So you can see that the hard link is saying, yep, they're all even Steven. The soft link says, this is, I keyed in something right here and it took 22 bytes to do it. But the main file got updated, as did the hard links. You know what? I hope this is helpful. This has been perplexing to me for several years as I'm learning Linux. I'm like, oh, I think they're a lot like a Windows shortcut, but the reality is it's a little bit different in the way that it works. And of course, as with Linux, everything, there's two ways to do everything. So we've got a hard link, we've got a soft link. We can do copy tac L to do copy something to a hard link, copy tac S to do something to a soft link, ln nothing to copy something from to a hard link, and ln tac S to make a soft link into a new file. So I hope you enjoyed that. I hope you find that useful, and I will talk to you in the next video. Have a great day.